In this lecture, I will explain what are the parts of a transformer. So the first part is transformer core. And second one is limb. And third is yoke. Fourth is windings. And fifth one is breather. And sixth is explosion vent. Seventh is conservator tank. And eighth is Boke's relay. See, the transformer core is made up of silicon steel in order to reduce hysteresis losses. High grade silicon steel is used and also laminations are provided. See, if you observe, so these are called the laminations. The core is laminated in order to reduce eddy current losses. We will discuss what is hysteresis loss and eddy current losses in the next lectures, coming lectures. Okay, so the core is made up of high grade silicon steel in order to reduce the hysteresis loss, and laminations are provided in order to reduce eddy current losses. What is meant by limb? The vertical portion of the transformer is called the limb. So for this transformer, how many limbs are there? Limb 1 and limb 2. So 2 limbs are there with this square cross sectional area, and the top and bottom of a transformer is called the yoke. This one is yoke. And generally the windings, we have a primary winding and one more winding is called the secondary winding. Generally the primary winding or secondary windings are made up of copper. Why? Because copper has low resistance. If the copper has low resistance, means I square or losses is also less. Then the efficiency will be improved. The performance will be improved with reduction of losses. And the primary winding is wounded on the limb 1 and the secondary winding is wounded on limb 2. And coming to this breather, see how many parts are there in this. So this is our transformer. And the transformer is kept in one tank. So this is a tank, and these are called the bushings. Here you can apply a sinusoidal voltage, and here you can connect a load. Through bushings only it is possible. And breather, just like we are breathing right inside, or we are taking air and we are leaving air. Similarly, same way, the small transformers, if you go for the small transformers, the tank is not filled with oil. So the tank is not filled with oil. Then the tank is connected to atmosphere. This tank is connected to atmosphere. It will take air from the atmosphere, which extracts the moisture. What is the function of breather? Means it will take the atmosphere, it will take the air from the atmosphere and it will extract the moisture. That moisture is not in contact with this oil. So that is the function of the breather. It does not allow oil to come in contact with the moisture. So generally in breather, silica gel is used. Silica gel is used as a breather and in breather. So after that is a conservator tank. In the conservator tank, the oil will be expands when temperature inside the transformer increases. So here the oil is filled in a tank. When the temperature of the oil increases, the conservator tank will be expands. And while it contracts when the temperature will be decreases. The function of conservator is to take up. So this conservator is to take up the expansion expansion and contraction of the expansion and contraction of the oil without allowing it. So without allowing it to come in contact with come in contact with the ambient air. And the last part is called the Bokeh's relay. It is a gas actuated relay. Whenever the fault will be occurs, the Bokeh's relay will be it will trip the circuit breaker. So it acts as a protecting, right? All types of internal faults, the Bokeh's relay will be reacts. The first part is core, and core is made up of high grade silicon steel. If you use the silicon steel, hysteresis loss can be reduced by providing a laminations. So between the laminations, providing the insulation. And after that, limb, the vertical portion of the transformer is called the limbs, and the top and bottom portion of the transformer is called the yoke. And the windings, we have two windings, primary winding and secondary winding. Both the windings are placed on different limbs. And fifth one is a breather. Breather is just like a breathing, like we are breathing, right? We are breathing air. Similarly, same way, it will takes air from the atmosphere and it extracts the moisture and does not allow the moisture into the oil. That is called the breather. In breather, silica gel is used. And after that, conservator tank. This conservator tank means the oil in the conservator tank will be expands if the temperature of the oil will be increased. If the temperature of the oil will be decrease, it will be contrast. And finally, this is explosion vent. If you observe this explosion vent, this is just like a bent pipe fitted on, this is called the main tank, which acts as a release. Okay, that is called the relief valve. It uses a non-metallic diaphragm and which burst. This will be burst when pressure inside the transformer becomes excessive. So when the pressure becomes transformer is excessive, this will be burst, and which will becomes excessive, which releases the pressure and protects the transformer. When the pressure inside the transformer becomes excessive, which releases the pressure and protects the transformer. These are called the parts of a transformer. Parts of a transformer. So coming to the next one, construction details. So constructional details of practical transformer. Constructional details of practical transformer. So there are two major parts. One is called the transformer core. Transformer core. And another one is transformer windings. Transformer core and transformer windings. The transformer core is made up of, yes, the core is made up of silicon steel. So if you use a silicon steel, the hysteresis coefficient is less, then hysteresis losses is also less. Neta B max power x FV, this x is equal to 1.6 for silicon steel. We can use the core materials as a transformer core means I will draw the square shape of a transformer So I am wound the winding on limb 1. Let us say this is called the primary winding, and another winding is also wounded, and now it is connected to the load. This is called the SW dot, means secondary winding. This part is called the transformer core, and these two are the transformer winding. This transformer core, if it is made with cast iron, the X value will be greater than 1.6. Greater than 1.6. So 2 cube is greater than the 2 square. If this X value is less, then only the hysteresis loss is also less. Where neta is called the Steenmerge coefficient. Where, what is this? Neta is called the Steenmerge coefficient, where F is called the frequency of the supply. Frequency of the supply. And V is the volume of the core. V is the volume of the core. Now, what is meant by hysteresis loss? From the intermediate concept, and B is on y-axis and H is on x-axis. If you draw the BH curve for a silicon steel, the gap between or area between these two means BH is small. This is for silicon steel. This is for silicon steel. If you go for cast steel, so the area is like this. BH curve is like this, where B is called the magnetic flux density. Magnetic flux density. This is called the magnetic field intensity. H is the, and B are flux and H are magnetizing component of current. So this area is more, then hysteresis loss is also more. The area under the BH curve, so we can define the hysteresis loss is like this. The area under BH curve is called hysteresis loss. Hysteresis loss. And this hysteresis loss formula is neta B max power x FV. Now for a silicon steel, the area will be less, then the hysteresis loss is also less. If you go for the air core, transformer, so air core transformer, there is no iron core, so the coil 1 is like this, and the coil 2 is like this, and the coil 1 is excited with sinusoidal voltage, and then it will produce as a flux. This flux will be linking with the secondary coil, and this is primary coil. Then if you connect a voltmeter here, definitely the EMF is induced. The EMF induced in this one is E1. Yes, the EMF induced here is E2. In between these two, air acts as a core. For this air, the BH curve is linear. But because of its material property, the BH curve is non-linear. For core materials. So in this core materials, for a silicon steel, the area is less. For a silicon steel. Then it is called as a hysteresis loss. So by using silicon steel, we are reducing the hysteresis losses. And the next loss is called the eddy current loss. What is meant by eddy current losses means the EMF which is induced in a windings is a useful one. the EMF induced in a windings is a useful one. In addition to that, because of conductivity of core, because of conductivity of core, there is a some EMF is induced in a core also. I am giving sinusoidal supply. Yes, sinusoidal current is flowing through winding, primary winding, and alternating flux will be developed. This flux will be linking with the primary winding and secondary winding. Then the EMF is induced in a primary winding and secondary winding. So it has N1 number of turns, it has a N2 number of turns. That is our transformer principle. And this flux is an alternating, and because of conductivity of the core, there is a some EMF is induced in a core. This EMF is called the eddy EMF. So due to time variant flux, in the core, an EMF induced in a core due to time variant flux is linking with the core, with the core changes, or time varying flux is linking with the core, and EMF is induced in a core. This EMF is called eddy EMF. Since the core is a closed circuit, the eddy current losses will be produced. And core has some resistance, then eddy current losses will be produced, I square R. So we have a different types of cross section. So that is square shape. This one is called the square shape of cross section of the core So we can use L shape, and another L will be connected in an opposite direction. Then code type of transformer is formed. So if I am taking E type and I type is connected like this, and another E is placed, in an opposite, exactly 180 degrees, and E is placed like this, then it will be looking nice, and also the air gap is also very minimum. This type is called the shell type of transformer. So this eddy current losses are produced here. How we can minimize the eddy current losses? By providing laminations. So that is our laminations. Yes, this is one small part. So that is 0.3 mm. The thickness of the laminations is 0.3 mm. So why I am drawing like this means these are called all the laminations. All the laminations are clubbed together. And eddy current losses formula is equal to K into B max square F square T square. K into B max square F square T square, where T is called the thickness of laminations. Where F is called the frequency of the supply, and B max is called the mag maximum flux density, that is Weber per meter square, that Bmax is equal to 5m divided by area. So now with this we understood that laminations are provided. One is L type and another one is reverse L type we are connecting. In order to avoid the air gap between the laminations, we are form the core type of transformer. Core type of transformer. And one more classification is there. One E type small lamination and another I type is also connected in opposite direction, and E type is connected at the top and I type is connected at the down. Then I connect a shell type of transformer. The types of transformers is very important. He will ask the difference between the core type of transformer and shell type of transformer. We have a two types. One is core type of transformer, and shell type of transformer. Okay, so we will discuss in detail in the next lecture.